Hello student, welcome in Rose project in 12th standard, which is conducted by Raya Shikshan Sanस्थas, Satara, myself, Minal Hemant Pawar from Sadguru Ghadge Maharaj College, Karad. My subject is physics. Today we are going to take topic number 10, magnetic effect of electric current. Today we are going to take topic number 10, magnetic effect of electric current. Today we will take last lecture of magnetic effect of electric current. We will see lecture number 6 of magnetic effect of electric current. In this lecture we will see toroid, important formulae, numericals and MCQs. We will see first of all the theory of toroid. Now see here, a toroid is the solenoid of finite length bent into hollow circular tube-like structure similar to the pressurized rubber tube inside the tires of the vehicle. That is, toroid is the similar to the tires of the vehicle. Like this tires of the vehicle, that is the structure of the toroids. Toroid is structure of the tires of the vehicle. A toroid is the solenoid of finite length bent into the hollow circular tube like the structure similar to the pressurized rubber tube which is inside the tire of vehicle. Now see here the schematic of the cross section of toroid as shown in figure by applying the Ampere's law. What is the Ampere's law? The Ampere's law is the line integral of magnetic field of induction over the closed surface is equal to mu0 time total current flowing to this closed surface. That is the Ampere's law, and taking into account the symmetry of this structure. Now we obtain the magnetic field along the center axis of the tube. We obtain the magnetic field along the center axis of the tube in terms of current. Now we consider the circular Amperian loop along the central axis of the tube. The magnetic field lines are concentric circle. In this toroid, the magnetic field lines are concentric circle in the toroid. Now see, the direction of the field is by the direction of current in the coil around the toroid. So Ampere's law, the C, that is formula of Ampere's law, line integration of B dl is equal to mu0 I. Now see here, where the I is the current, net current encircled by loop. I is the net current encircled by loop. See in this diagram here, the concentric circle, that is toroid is the solenoid bent into the hollow circular tube-like structure. The pressure is the tube of the tires like this here, and there is Amperian loop is the imaginary circle drawn on the here is, that is known as Amperian loop, where I is the current, that is net current encircled by the loop. The net current encircled by the loop. Therefore, here that is circle that B dot 2 pi r is equal to mu0 in. That is B dot 2 pi r. dl is equal to here 2 pi r is circle. So mu0 here instead of that is n, we can write in. N is the total number of the turn in the toroid. N is the total number of the turn in the toroid as the integration over the full length of the loop, that is the 2 pi r. Integration over the full length of the tube is 2 pi r. So we get equation B is equal to mu0 in upon 2 pi r. This is the equation, the magnetic field along the toroid, the magnetic field along the center of the toroid. That is B is equal to mu0 in 2 pi r. N is the total number of the turn in the toroid. See here, by equation 2, B is inversely proportional to the R. That is, unlike the solenoid, magnetic field is not constant over the cross section of the toroid. Here magnetic field is not constant over the cross section of the toroid. Therefore, B is equal to mu0 in 2 pi r. It is the equation of the magnetic field of a toroid. Now let me see magnetic field due to the electric current formulae. We will see that in total already we have seen that some formula of that is throughout the section. We will revise the which one formula we have learnt, that is throughout the section. This is the important formula for solving the example. Here First formula is the Lorentz force F is equal to QE plus QV cross B is equal to QVB sine theta. That is the Lorentz formula. Second one is magnetic induction B is equal to F upon QV. Third one is cyclotron motion QVB is equal to mv square upon r. There mv is equal to p qvb. The time period of full revolution T is equal to 2 pi r upon v, 2 pi m upon qb. Now next formula is the frequency of revolution Fc is equal to qb upon 2 pi m. All formula is very important formula. So these all formula keep in mind. The kinetic energy of revolution 1/2 mv square, substituting the value of v, that q square b square r square exists upon 2m. Next one is the magnetic force on wire. Fm is equal to ILB sine theta n. Arbitrary shaped wire. Fm is equal to I integration of dl cross b. Magnetic dipole moment mu is equal to NIA. Torque acting on the magnetic dipole tau is equal to mu b sine theta. Magnetic potential energy of dipole mu is equal to minus mu b cos theta. Then next important formulas are there. See here. By Saward's law, current in long straight wire B is equal to mu 0 I 4 pi r. The force of attraction between two long parallel wires F upon L mu 0 I1 I2 upon 2 pi d. Next one is magnetic field produced by current in the circular arc, that is mu 0 I upon 4 pi r into theta. Magnetic field by current in circular loop Bz is equal to mu 0 I r square upon 2 in bracket z square plus r square 3 by 2. Magnetic lines for current loop Bz is equal to mu 0 Ni upon 2r. Next one is magnetic moment of circular loop Bz is equal to mu 0 Ia upon 2 pi z cube. Electric dipole moment of circular loop E is equal to 2p 4 pi epsilon 0 z cube. Ampere's law, that line integration of BDS is equal to mu 0 I. Magnetic field on long straight wire B is equal to mu 0 I. Magnetic field on solenoid B is equal to mu 0 Ni. Magnetic field on the toroid B is equal to mu 0 Ni upon 2 pi r. These all formulae we are going to use in for solving few example. We will see some numericals. See, first of all, we have to read this numerical. Calculate the value of magnetic field at a distance of 2 cm from very long straight wire carrying current of 5 ampere. That is mu 0's value is given. Mu 0 is the permeability of medium. Mu 0 is equal to 4 pi into 10 raised to minus 7 omega b Weber per ampere meter. That is given. First of all, we should be read this example. First of all, we have to read this example carefully. Then which one term is given, that first of all note down here. Then after see, given mu 0 is equal to 4 pi into 10 raised to minus 7 Weber per ampere meter. Current is given, I is equal to 5 ampere is given. Radius is given, distance 2 centimeter. We have to convert centimeter into meter. 2 into 10 raised to minus 2 meter. Now we are going to use the formula of magnetic field along the long straight wire. This formula B is equal to mu 0 I upon 2 pi r. Substituting these all values in this equation. So we get, if substituting the value of mu 0, substituting the value of I, substituting the value of r. So we will solving this total example. We will get 5 into 10 raised to minus 7 into 10 raised to 2. So last answer will get B is equal to 5 into 10 raised to minus 5 Tesla. After solving this full example, that we will get last answer is 5 into 10 raised to minus 5 Tesla. That is the important. We have to write the unit of each, that after solving the example. That is C. You must be write the unit of this after solving example of that answer should be write in units here. That second example is here. First of all, we have to write this example. A very long straight wire carries the current 5.2 ampere. What is the magnitude of the magnetic field at a distance 3.1 centimeter from the wire? Now here given is mu0 is equal to 4.2 10 raised to minus 7 Weber per ampere. That is given term. That is some one term is also given is here. I is given, current is given 5.2 ampere, R is given 3.1 centimeters. We have to convert into meter. 3.1 into 10 raised to minus 2 meter. Mu0's value is given. We have to find that is value of magnetic field. We will see formula. B is equal to mu0 I upon 2 pi R. Same formula used here. Last example also we have to use this formula. Now also we are going to use same formula. B is equal to mu0 I 2 pi R. Thus substituting the all values of mu0 I and R's, let solving this problem or solving this solution, we get last equation or last answer 8.35 into 10 raised to minus 5 Tesla. After solving this example, we get last answer is 8.35 into 10 raised to minus 5 Tesla. Next example is here. Current of equal magnitude flows through the two long parallel wire having separation of 1.35 centimeter. If the force per unit length on each of the wire in 4.76 into 10 raised to minus 2 Newton, what must be I? Here, that is, first of all, we have to write this example. Then after which one is given, that is first write here solution. Given term is we have to calculate the I's values. D is equal to is given 1.35 centimeter. That centimeter we have to convert into meter. 1.35 into 10 raised to minus 2 meter. Force per unit length is given 4.76 into 10 raised to minus 2 Newton. I1 is equal to I2 is equal to I. Therefore, mu0 is equal to 4 pi into 10 raised to minus 7 Weber per ampere. Now, here, that equation we have to get this answer here. See, F upon L, we are going to use the formula of the force of attraction between the two parallel wire. F upon L is equal to mu0 I square 2 pi D. Substituting the value of all values, we should convert this equation into in I square. That I square is converting, so we get that F into 2 pi D upon mu0 upon L. So we get here that substituting all values 4.76 or that F upon L's value also we have to substitute 4.76 into 10 raised to minus 2 Newton into 2 pi into D's value is 1.3 into 10 raised to minus 2 meter and mu0's value 4.2 10 raised to minus 7. Pi cancel here 2. After solving this full equation, we get I square is equal to 3.213 into 10 raised to 3. Now we have to here that we have to take the square root here. We have to take the square root of this for this that values. So we get answer of this example I is equal to 5.668 into 10 raised to into tens. So I is equal to we get 56.68 ampere. That is the answer of this example. I is equal to 56.68 amperes. That is the answer of this example. Now see, we will see the some numericals here. There's some numerical. See, first numerical, a rectangular coil has 100 tons, each of area 50 centimeters square. It is capable of rotation about an axis joining the midpoint of two opposite sides. When current of 5 ampere is passing through it while its plane is right angle to the uniform magnetic field, it is experiences a torque of 5 Newton meter. The magnetic field will be, that option is given: A, Tesla, B, 2 Tesla, C, 0.5 Tesla, D, 1.5 Tesla. Now solutions here, that we have to use the formula B, that is 1 upon, I NLA. I NLA, that is the torques, that is which one? That is the moving coil galvanometer's formula is there. That I's value is given, is current is given 5, L is given here, area is given 50 centimeters square. So convert meter square, 50 into 10 raised to minus 4 meters square. Here see, number of the turn is 100 and torque is given. So here it is torque, it is not I, it is not L, it is torque value. Tau is given 5 here. So after calculating this whole term, we get 5 cancel, we get the answer 2 Tesla. So answer will be B, 2 Tesla. Answer will be B, 2 Tesla. The next numerical is here, a winding wire that which is used in frame a solenoid can bear a maximum 10 ampere current if the length of solenoid is 80 centimeter and its cross-sectional radius is 3 centimeter. Then the required length of winding wire in M, B is equal to 0.2 Tesla. That once again see example, a winding wire which is used to frame a solenoid can bear maximum 10 ampere current if the length of solenoid is 80 centimeter. Its cross-sectional radius is 3 centimeter. That required length of winding wire in M is equal to, B is equal to 0.2 Tesla. A, that option is A, 1.2 into 10 raised to 2 meter, B, 4.8 into 10 raised to 2 meter, C, 2.4 into 10 raised to 3 meter, and D, 6 into 10 raised to 3 meter. That we are going to use formula B is equal to mu 0 Ni upon L here. C, given term is B is given 0.2 Tesla, mu 0's value we are knowing 4.2 10 raised to minus 7 Weber per ampere meter. Number of the turn N, I is given 10 ampere, that is length of solenoid is given 80 centimeter. We have to convert into meter, that 80 into 10 raised to minus 2, so 0.8 meter. That is number of the turn N. After calculating, after solving this full term, we get N is equal to 4 into 10 raised to 4 upon pi. So here the length of each term, therefore 2 pi r into N, length of each term. 2 pi r means length of each term, that L is equal to 2 pi into r's value is radius. The radius is given 3 centimeter, that we have to convert into 3 into 10 raised to minus 2 meter, and N's value also substituting. That after solving this full equation, that we get 2.4 into 10 raised to 3 meter. That answer will be C, 2.4 into 10 raised to 3 meters. Now see, today's lecture we have seen the magnetic field due to the center of the toroid, some important formulae which we have to use for solving example, some numericals and some MCQs. Thank you very much.